VLSos here. This is a video lesson on functions and the notation for functions. A lot can be said about functions and notation, so this lesson is going to focus on some of the basics. And you can't get more basic than a definition. Function is an equation in which for every input there is only one corresponding output. What do we mean by that? Well, let's introduce some more things and maybe that'll help explain. Teachers love to think of functions as machines. It's just a conceptual tool, and I'm drawing a box to represent that machine. At the top of the box, we have a hopper for input. And what we're putting into mathematical conceptual machines are numbers. Like we could put a 2 above there as if it's going into the hopper. Teachers love to think of functions as machines because we get the idea that there is some mechanism in there, like an old school gears and springs and levers, that process that number. And they do it mechanically such that the output is the same every time. So if you put in a 2, the machine is going to do something with the 2 and it might output another number. But this concept is like it's a mechanical process. It's reliable and consistent because it needs to get across the idea that if this is a function, every time we put the same input in, the same corresponding output is going to come out of the machine. If we put a 2 in and sometimes we get a 5 and sometimes we get a 7, then this mechanism isn't reliable because we don't know quite what we're going to get each time, and therefore it would not be called a function. This machine, in this case, is a math process. What's happening to the 2 mathematically? We don't know yet. Another thing that we often do with functions is we make tables. T-table, in which we can represent the input with the variable x. The output is often represented with the variable y. And if we had a mathematical process, we could input a 2 or a 1, a -1, anything we wish. We could imagine that this mathematical process will output a 5 when we put a 2 in. Maybe it will output a 3 when we put a 1 in. And if our input is -1, let's say the output is -1. Tables are a very good way to organize information. And if it's done this way, the information can be plotted. The x is 2 and y is 5 become coordinates, an ordered pair that we could graph on 2 axes. Typically, the horizontal axis is the input axis, in this case x, and the vertical axis is the output axis, in this case y. Now, for a graph to be complete, we need at least one tick mark labeled on each axis to understand what the intervals are and where the numbers lie on the number lines. I'm going to plot the point 2, 5 when x equals 2, y equals 5, and that would be a point up there. Plotting another point, 1, 3, would be 1, 3. And plotting the point -1, -1, we'd be down here. We don't know what the mathematical process is. We've represented it as a machine, a chart, an idea. We've represented as a t-table, collection of data and points, and we've represented it graphically, but not the entire thing. If we investigated these numbers, we might chance upon the equation that this is the graph of. The equation for this, with a little bit of analysis, is 2x plus 1. With the equation, I could use it to make more points in my table. If I chose to input 3, then the x would be replaced by 3, so I could find the corresponding y value. If I do that, I get 2 times 3 is 6, add 1 makes a y value of 7. I could put that in the table. I could plot this. And if I kept doing this and I had many more points, I could graph them all and complete the graph, which in this case is a line. Functions have names. We could call this machine the f machine or the f function. And when we choose to give functions names so that we can refer to them, if there are many functions, each one having a unique name, means that we could refer to them by name. We could change this y into function notation to make use of its name. So instead of y, if I replace it with f and then x in parentheses, this notation I could voice f of x, where the name of the function is f, as if the name of this machine was f. I could make it equal to the same mathematical process. F of x is equal to 2x plus 1. This is function notation. And with function notation, I could ask myself, well, what is the f function if its input is 3? That's going to be the process. 2 times the input plus 1. And we already know from doing the math in our t-table that the value of the function at 3 will be 7. Here I have general function notation, and here I am using function notation to find the value of the f function at a specific point.